Hello, we continue working with quadratic functions. I want to write that quadratic function is a function of the form, let's say I call it f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, and we add the condition that a cannot be 0, because otherwise we wouldn't have a quadratic function, we would have a linear one. So this is written in what we call standard form, and it's written in notation, in function notation. We could also write y is equal to ax squared plus bx plus c, and we do write it this way sometimes. This is not the only form we can write a quadratic function. We could also write that our function is given by a constant a multiplying x minus b times x minus c, and this is what we call factorized form. And again, we have the same conditions for a, b, and c, that we want them to be real numbers and a different from 0. Let me add this here, so it also holds for that. There is yet one more way of writing it, but we are going to get to this later. Of course, if you expand the factorized form, applying the distributive property here, multiplying x times x and x times negative c and so on, you will get to write it in standard form. And later on, we're going to see that if it's possible to write the factorized form, we're going to be able to do it from standard form as well. Okay, we will talk more about this later, but over here, I just wanted to give one example. Let's say I'm going to write that f of x is equal to 2x squared minus x minus 1. And I want to know what is the value of the function when x is equal to 2 and when x is equal to negative 3. So find the value of the function when x equals 2, x equals negative 3. So let's do this. We need to substitute the value of x by 2 first of all. So we're finding the value of the function at 2. So we're going to have 2 multiplying 2 squared minus 2 minus 1. So for the first term, we have 2 squared, which is 4 times 2, 8, minus 2 minus 1. So the value of the function at 2 is 5. If we want to check the value of the function at negative 3, let's be careful with the signs. We're going to have 2 multiplying the square of negative 3. I'm going to use brackets for that. Minus, and then we have the value negative 3. Brackets again will help. Minus 1. So we have over here 2 multiplying negative 3 squared. So negative 3 times negative 3, that's 9. And then we have minus negative 3, so minus minus, that's plus, so plus 3 minus 1. So this is 18 plus 2 is equal to 20. Let's say this was part A of our problem, and now for part B, we want to find the value of x now. If we know that when we evaluate the function, the result is negative 1, and then we also repeat this for the value of the function being equal to 0. So for part B first, we want to know for which values of x it's true that 2x squared minus x minus 1 is equal to negative 1. So we are trying to solve a quadratic equation. In this case, it's an easy one to solve because we can cancel negative 1 on both sides. And then what we're trying to find out is when 2x squared minus x is equal to 0. We can take x as common factor, and then we're going to have that x multiplied by 2x minus 1 has to be equal to 0. You can check if I expand again, I will have x times 2x, that's 2x squared, and the x times -1, that's minus x. So I factorize this fine. And now we can apply the null factor law to solve it. If the product of two expressions is 0, that's either because the first one is 0, so x is equal to 0, or the second one is equal to 0, so 2x minus 1 is 0, and this happens exactly when 2x is 1, and this happens exactly when x is 1/2. So there are two values of x that when we apply the function the result is -1, and those values are x equals 0 and x equals 1/2. For part C, we want now to solve the function equal to 0, so we want 2x squared minus x minus 1 to be equal to 0. So we need to solve a quadratic equation, and we know how to do that because we know, for instance, the quadratic formula. So we can say that x is going to be the result of 2. Let's write here a is 2, b is -1, and c is -1. So the formula applied here will be minus -1 plus minus square root, then we have -1 squared, minus 4 times a times c, and all of this divided by 2 times a, so 2 times 2. So we have here -1, that's 1, plus minus, and then we have 1 plus 8 inside the square root divided by 4. So this is 1 plus minus 3 divided by 4. So there are two options here. It can be either that x is equal to 1 plus 3 divided by 4, so 1, or it can be that x is equal to 1 minus 3 divided by 4, so x is equal to -2 over 4, so -1/2. So those are the two values that could give me, when we apply the function, the result of 0.